So welcome everyone, and thank you so much for coming. I'll start with a quick introduction. My name is Drew Lebowitz. I am the principal and managing director of PowerSwitch. We are an energy storage advisory firm. So we're focused on providing services mostly to developers of energy storage projects, but we also work for manufacturers, banks that are financing the projects, even some operational projects. So really great to be with you today. Just a couple ground rules for the session. I would love to make this as interactive as possible. Oh, somebody said it's not in presentation mode. Hang on a sec. Let me make that.
Yeah, I see the presentation, so I think it is in presentation mode.
All right. I'll keep going along.
No, I see all the slides and your menus above.
Oh, really?
Yeah. So do I.
Looks like you haven't started the slideshow, so maybe we're on the wrong monitor.
Okay, sorry about that. Give me a sec here. There we
Perfect.
go. How about now?
Great.
Okay. So now we got the little thing there. All right. It'll go away in a sec. All right. So thanks everyone for joining. I want to encourage everybody to make this as interactive as possible a session. So feel free to jump in if you have some questions. Just speak up and we can chat through. Just a quick bit about PowerSwitch. As I mentioned, I'm the managing director. I'm also the lead author of the BESS book. Some of you might know this, the text in the energy storage field become one of the leading texts. We're actually in the process now of coming out with a Spanish edition, which will launch next month, and a new edition of the book because so much is changing in the field. If you're interested, you can find that on Amazon. PowerSwitch offers owner's engineering, independent engineering, and we do a lot of trainings as well as expert witness work. So that's become a big part of what we do at PowerSwitch. And I should point out too, we do some work in the energy access field, which is international work involved in expanding power grids to places that don't currently have power grids. Lastly, before we dive into the presentation, we also run the BESS 100, which is a real-time visual ranking of the 100 biggest battery projects in the world. You can check that out. You can kind of spin around the globe, see where they're happening. We update it more or less once every quarter. So it's a really cool resource for having, just knowing where those big projects are. I thought I'd kick it off with just a couple pictures of some of the big projects that we work on. You can see that a lot of these projects are hundreds of storage containers. And you can see on the bottom right there, that's an inverter container. They start all looking kind of similar, but we're going to talk through today what some of the key trends are in this space and how the products are evolving. Just let's take a look. This is a rendering, but it gives you an idea of what a system might look like. This is listed as a 240 megawatt 2-hour system. I think this is actually maybe a little bit old because now the densities have gotten a lot higher, so you can do that same size with fewer containers. But most of these projects are laid out close to a utility scale substation. There's typically a project substation, which is what we see on the right. And then you have an array of battery containers and inverters and transformers, all of which compose these systems. When we say utility scale, I typically talk about things that are 10 megawatts and up. I remember when I started my career at DNV, we were working on like a 20 or 30 megawatt project, which was the biggest in the world. And now the biggest in the world are 500, 800. I've heard of some gigawatt scale projects coming. So that was really in only the course of about 5 years, the projects have gotten really big. And that is one of the big drivers of why the innovation in this space and the products in this space has happened so quickly. So I mentioned that, a lot of this is kind of coming on the heels of RE+. And so we're going to talk a little bit about the conference. But right before RE+, I posted this on LinkedIn that was kind of a roundup of here are the products that are out there in the space. And I just wanted to run through. So we did the top 20 products. You can see here, like Tesla, for example, had their Megapack 2 XL product, which was a 3.9 megawatt hour. You can see those ratings there. On the left is megawatts, on the right is megawatt hours. You can see they sort of range from, that 3.9 up to, CATL had this stack container, which is one 20-foot shipping container on top of the other. So that's how they get much higher ratings. And the numbers in blue are the kilowatt hours per square meter. So that was just taking the rating in energy and dividing it by the size of the container. Most of these containers are 20-foot shipping container size, although we have seen that a lot in the industry has gone back to doing a smaller, like more modular type setup. And we'll see that in a second here. Here's another page, part 2. Again, there's been a lot of new entrants coming into this field, all kinds of interesting products that are popping up. You can see they range anywhere on the kind of lower end of 2 to 3 megawatt hours up to the higher end, having that 7, 8, and even I think CATL hit 9 megawatt hours in that same footprint. So let's talk a little bit about the conference. The conference had started as SPI, which is Solar Power International. So it was actually more of a solar focused conference back in 2004. So this is the 21st year they've been doing it. It's up to about 40,000 people. It's so big. They generally only do it in either Las Vegas or Anaheim. Those are also 2 big areas where you have energy storage and solar projects. So that's one of the reasons it's there. It's really the premier show for vendors of solar and battery products. I think maybe 5 or 6 years ago, batteries were like off in a little corner of the part of RE+, or it was SPI then, and they realized it was becoming so big, they changed the name to RE+. And I'd say at this year's show, it was like probably half and half. Like energy storage has really continued to dominate, especially in the face of the change in the law provisions around tariffs and FIAC, which we're going to get into. It was kind of cool when I was flying in. This was a picture I took right out of the window of my plane. We could play a little Where's Waldo. Does anybody see on this massive solar install where the battery is? I like this picture because it kind of points out like how small the energy storage project is, like in acres compared to solar. So for those of you who could find it, it's down there in the corner. It's those little white boxes. And then I showed a close up here. I don't exactly know. I was trying to look up exactly what project this was. I couldn't find it, based on the layout. But suffice it to say, it's a very big solar project coupled with energy storage. And we're starting to see that a lot of solar projects, if not the majority of solar projects built today, have some component of energy storage. I think the industry got its start with solar and storage coupled together, and they've moved on now to have more of standalone storage. So just a couple scenes from RE+. You can see all the vendors are out there kind of trumpeting their new technology. I like this one on the right. You can see solar born and raised in the USA. So that is, I think, a theme. That was solar focused, but a lot of the booths this year were kind of trumpeting, where is the thing made? Is it compliant with the new laws and regulations? You can see on the left here, this is an inverter or PCS, one of the leading products from EPC Power. They pride themselves on being US made. I think they have some components that are made overseas, but the most of it is put together here in the US, and that's become a real advantage. On the right, you can see a company, Narada, where they are sort of unabashedly a Chinese company. They're made in China. They're not trying to diversify, as far as I know. So you kind of run the gamut of companies that are really aggressively doing made in the US, other companies that are made in China, and everything in between. One cool thing you get to see at these shows is there's a lot of really interesting displays. On the left, you can see what we would call a module, and that module is made up of cells inside. Those modules go into racks. You can see in the middle, there's kind of a rack populated with 4 modules, and then all the racks get put into containers. You can see on the right, and they get built up. That's an LG Energy example of all those modules stacked up into their product. And of course, we did have a little fun in Las Vegas. This is what they call Solar Fight Night, which was a kind of a club where they got out. They had kind of a Cirque du Soleil battle between Mother Solar against Big Oil, which was kind of fun. So let's go on to the trends. What did we see out there in the showroom? So I'd say kind of the first big trend we saw is the rise of what we would call the AC block. So AC block refers to the fact that we have some battery products, which we would call a DC block. And all that means is that in the container, these are just the batteries. When I say just the batteries, it's just battery racks inside that container. There is a collection system, meaning how they all come together, usually racks put together in parallel. There's a cooling system, there's fire systems. But the important thing is you don't have an inverter, meaning that the DC block has its terminals put out DC voltage. Typically, the range is anywhere from 1100 up to about just under 1500 volts. So we would call that 1500 volt rated system. So it's 1100 when it's fully discharged, up to about 1450 or a little higher when it's fully charged. That's a DC block product. Now, conversely, an AC block product is one where you actually have the PCS inside the battery enclosure. So with that DC block product, you have to have that inverter or PCS outside. Usually it's on a separate pad pretty close to where the batteries are. But we've seen this big trend is that the AC block products have the inverter baked right in. What I'm showing on the screen here on the top right is the e-storage product. That's a division of Canadian Solar. We're going to do a little deeper dive on their products. I hate to single out any one supplier or other. To be clear, PowerSwitch has no affiliation with any one supplier or other, but I thought this provided a really good example of the top. It's the DC block, just the batteries. On the bottom, you can see it sort of has that upper and a lower portion. The lower portion there is the inverters. So you have your batteries on the top, inverters on the bottom. And the nice thing about this product is it puts out, I believe this one's anywhere from 480 to 600 volt AC power. So you still would typically hook that up to a medium voltage transformer and step it up to anywhere between, say, 20 and 40 kilovolts for distribution around the site. But that trend has permeated both residential, commercial, industrial, and we're showing here utility scale. The reason that they're doing it this way is there's a few different reasons. One is it makes it fewer components on site, so you have less things to hook up. Two is there's a simplicity so that you don't have to have a different brand inverter talking to a control system, talking to the battery product. You kind of just have that integrated unit. And lastly, on an overall site basis, so if we look at the acreage of the site, if you use these AC block products, you can have a higher density, so a higher number of megawatts or megawatt hours per acre on this type of using this type of product. So you have all these things combined to mean that it's a valuable option. To be clear, not every project wants this. There are some projects where they prefer having a DC block. A DC block is a little more versatile. It has a lot of abilities to meet some needs of projects and some how do I put it, a little more versatility in the sizing of those projects. For example, a lot of the AC block products, they would come in either a 2-hour or a 4-hour variation, right? Because the inverter is baked right in there, so you kind of have to pick 2-hour or 4-hour. Whereas there are certain markets, for example, in Chile, the way the market is structured, it's a 5-hour market. So you would rather have a 5-hour battery in those markets. When I say 5-hour battery, what that means is if you were to discharge at full power, you could do that for 5 hours until you got down to the lowest state of charge. To be clear, a 4-hour battery can discharge as if it were a 5-hour battery, but there's some inefficiencies there, which mean that you're sort of paying for some capacity you don't actually need. So DC block, a little more versatile. AC block has these advantages in space and less complication. Price-wise, DC block tends to be the more cost-effective option. So if we look at, just if you're only focused on dollars per kilowatt hour, usually the DC block will be cheaper. Although I will note that some of the AC block products have becoming more and more competitive. And when you take into account all those other things, such as higher density and some complications, they become even more competitive. So that's the first trend. I'll stop there for a second. Any comments, questions on this trend? Have people seen this in the market?
Hey, Drew, this is Matt. I had a question about the round trip efficiency difference between AC and DC.
Yeah, great question. So round trip efficiency is, if you take all the energy, put it into the system, take it all out, you get the differential there. So there's always going to be some sort of losses, just thermodynamics. Now the really high-end products, they can do up to about 90 or even 91% efficiency at the point of interconnection. So that means when you're going through everything, the high voltage transformer, medium voltage transformer, the inverter, the battery, the back out, 91, which is really impressive. The industry has really come a long ways in that regard. I wouldn't say there's a definitive advantage to AC block or DC block. Really most of them are very similar technology. You're still going through an inverter, you're still going into and out of the DC block. So from what I've seen, there isn't a huge difference on that. I would say the difference is that there's a little less complication, I should say, in the way that a AC block system works, because they would provide a performance guarantee right at the terminals of the battery, which is the AC terminals, as opposed to most of the time with a DC block, you only get the performance guarantee. And when I say performance guarantee, it's energy and round trip efficiency for usually the life of the system, 20 and sometimes 25 years. So I think technically there's no real huge difference in terms of the round trip efficiency you'll get AC block versus DC block. But contractually speaking, and like how complicated it is, there's a simplicity of having the round trip efficiency for an AC block product at the AC terminals as opposed to the DC terminals. I see there's a couple others, maybe we'll limit it to one more question because I want to keep the presentation moving. I think Jack had a question.
Yeah, so I just wanted to make two very minor things. First is that in Europe, we see a lot of DC block products. And I think that's just simply because of the cost scale when as you quite rightly mentioned about the kilowatt hour, dollars per kilowatt hour for DC block systems tends to be a bit lower in Europe, at least anyway. I'm not sure if you might touch later on AC and DC coupled systems as well, how the PV is routed. So if you have any information on that to share, that'd be great. But if not, I'll just be quiet and let you carry on.
Thanks, Jack. Yeah, I think different markets sort of tend to attract different products. Some of that is sort of trends, like there may be one supplier that kind of goes more aggressively after one market or other. I would say the standard, quote unquote, standard markets where you have a 2-hour or 4-hour, you tend to see a lot of AC block and DC block, whereas those markets where you are having kind of unique characteristics, such as I mentioned Chile, like Taiwan, for example, a 3-hour market, those you tend to see more of the DC block. Interesting to hear that in Europe, you're seeing more DC block. I think over time, we'll start to see a mix, but I don't think it's a case where it's like one is going to dominate. I think it's more of a case of we're going to see, a mix of the two different products or product families out there kind of competing for different parts of the market. Okay, moving on to trend number 2. So trend number 2 is just beware falling prices. I know we had someone from Walmart before, so I stole that tagline from Walmart, but it's very true when it comes to batteries. It's a little grainy here, but you can see on the left there a chart that shows, this is from Bloomberg, from 2015 up to 2024, we went from $463 for the battery pack. To be clear, when we say pack, in this case, it's generally considered the module. So those are those things that get populated into the rack. Of course, that's like the key component. $463 all the way down to $115. So massive decrease. If you go all the way back to 2013, it's a 700% decrease. So those prices have come way down. If we look on the right, I realize this is in Spanish. This was from the Spanish edition of the book because we just updated it. But you can see, from 2022, we were about $400. This is on a project basis. So this is everything, including the inverter, the battery, like BOP, like interconnection, everything. We go 400 all the way down to today. We estimate this is to be clear, this is actually for like non-US markets. US tends to be a little bit higher than this just because of tariffs and other things. But international markets outside of the US tend to be somewhere around $165 a kilowatt hour. It's estimated that next year we might get down to 145. Just continues to fall. Because of that, you've seen a lot of new applications. So there are places where the battery systems just didn't pencil before, and then they've started to kind of make a lot of sense. I thought hearing from Rachel at Walmart, hearing about what she saw as these applications. These are things that even just a few years ago didn't make sense from a cost perspective. We'd also seen just like globally, if you were to look at the number of installs, it's just kind of going up exponentially. And I think a lot of that is a product of these prices coming down. As one interesting reference point, we just saw a procurement in China of utility scale, the battery, the PCS, and the control system going for much lower, like down somewhere close to $65 a kilowatt hour. So I think of that as kind of a preview. Like if you take tariffs and everything else away, like the tech itself has gotten to the point where it's like that's almost half of what we're paying. So I think we're going to continue to see costs falling and falling and falling.
Sorry, so that
Hey.
65 would be equivalent to the prices we're seeing on the left or the right? You said including the battery, the pack, and what else?
Yeah, it would actually be somewhere in between those two.
Okay.
It's a little confusing.
Yeah.
I think the corresponding number would be, we are seeing, I think Bloomberg had said at the end of 2024, the corresponding number there would be, I think it was $165. So they're like less than half. I think that's even fallen still lower. It's common when you get these quotes, you would get a quote for battery, PCS, and controls. So that would all be under a single scope, and then you would have a BOP contract sign everything else, or EPC contract. So it's like all the key components were somewhere there. It's pretty close to about half of what we're seeing in the US.
Drew, this is Randy. If you drew that same chart for O&M costs, or asset management costs, do you think it would look like the same or different?
Yeah, that's a good question. I think you're not going to get nearly the fall you're going to get as we've seen here. I think NREL has some great data on that. If you look like where their charts are for O&M, I think it just is a function of there's only so many gains to be made on O&M. But that said, I think like everything's getting better. They're getting better at monitoring systems. The guarantees are getting better and longer. Fewer truck rolls, better cooling systems, for example. I remember visiting systems that were built in like 2015, and it was like maintenance crews out there every day. And now, I mean, these things, even gigawatt hour scale projects are, you might have a truck roll every couple months, once things are kind of worked out of the sort of teething period. So I do think there's a lot of gains being made there, but I think they're probably not quite falling as dramatically as you're going to see on the CapEx side. All right, let's keep it moving. So trend 3, I say bigger, better, and maybe better. So everything seems to be getting bigger. We went from, I think the CATL had a really good display where they kind of started at a 285 amp hour cell and went up to like the latest one is 565 amp hour. To be clear, like those cells are almost always 3.2 volts nominal, meaning, you'll have like 400 of these cells in series in most of these racks. But the cells themselves are getting bigger. That just means, you can use fewer cells, get more kilowatt hours. I saw someone had like an over 1,000 amp hour cell. So they keep getting bigger. In turn, the amount you can pack in a 20-foot shipping container is going up. So, even just like say 5 years ago, we were talking about like 1 megawatt hour, 1.5 megawatt hours, and we're going to see some examples on that in a second. But now we're up to 7 megawatt hour plus. CATL says 9, but that's really because they're stacking one on top of the other. But the companies that are using just a 20-foot shipping container, I think we've gotten up to about 7 megawatt hours. So really impressive gains there. That's driven by the change in cell. It's driven by some of the architecture of the products themselves. As I mentioned before, one of the big drivers for having higher megawatt hours is that you can fit more megawatt hours into a smaller footprint. We're seeing, if I ran the numbers on it, at 250 megawatt hours an acre, that was the number that Tesla said with their new product you could do, the Megapack 3, or what they call the Mega Block. That goes to $50 million per acre. So, to go back to that picture of, what we're seeing of like 1,000 acres of solar, it might have 5 acres of battery. So, it's just a very high density. I think in most cases, like if you're in the desert, that doesn't matter as much, but especially as we talk about more kind of installs that are in, urban areas, I think that makes, it makes the projects pencil more and especially from a permitting point of view, if you can put more in a smaller area. As I mentioned before, there's fewer boxes, fewer things to connect, all that brings down your BOP or balance of plant costs, reduces project timelines. However, I would point out that, the more energy you put into one of these boxes, it is a greater fire risk. The energy storage industry has made a lot of strides in safety. I'm not going to get into that today, but that's one of the big areas we saw at the show. Large-scale fire testing has become commonplace. But if you're, for example, like CATL, stacking one of these things on top of one another, that's going to burn hotter. if there's more things to burn on top of another. So not to say it's insurmountable, but it does create some new safety considerations. Any comments on these massive containers or products we're seeing?
I do have a question.
Go ahead.
Apologies. I do have a question about, as we look at some projects where, we're trying to get more energy density into a smaller footprint, all that makes sense. Do you see a trend towards moving to, especially in applications like AI and things like that, where they're moving more, maybe away from energy and more towards power?
Yeah, that's a great question. So just for a little bit of background on that one, when we say like energy or power, usually these LFP products are pretty squarely within a 0.25 C to 0.5 C. And what that means is that it's either a 2-hour or a 4-hour battery. We have seen some that can stray outside that, but like almost all these products kind of come in one or the other. So what it is that you physically can get, and if you'll notice this when I show the products, like almost always the power rating is half of the energy rating, meaning it's for a 2-hour system. But what they do is they say the exact same physical product, they will write you a different performance guarantee, meaning like over 25 years, like what the curve will be if you use it at the lower power, right? And so generally you can say, I want the high power version, which is the 0.5 C, or some companies use 0.5 P. And other companies will say, I want the energy version, which is the 0.25 C or P, which refers to a 4-hour system. It's become pretty standard. As I said before, just because you have a 4-hour system, you can use it longer, right? You can always say, I want to use it as a 5, 6, 7-hour system. We have seen batteries start to become more competitive, the same LFP products in 6-hour and 8-hour markets because of falling costs. But I generally say that's like kind of the divide I see in these LFP products when it comes to like high energy versus high power.
So for instance, if, I guess where I'm going with this is, let's say you have like a data center, an AI center, that's a 100 megawatt type of facility. There's a lot of frequency regulation. They have severe economic headwinds if there is a power outage or anything like that. That it's incredibly costly for them. And so, but they have backup generators. They have other things like that that will take the place of for long-term storage if needed. But they need 100 megawatts, and so to do that with 100 to 200 containers, 400 containers even, depending on the C rate, that's a lot of space, and it's very costly. And so, we've seen interest in things like 5C type of containers using alternative chemistries.
Yeah, sorry to cut you off. I know we were kind of running short on time, but yeah, the systems I'm seeing generally are 2 to 4 hour, and there are some, I did see some that were like best for UPS applications, like it's a specialized application. So physically can be done. I think it just comes down to the commercial terms that most of these products just aren't going to offer that type of performance guarantee. If you don't have the performance guarantee, you don't get it financed. So there are some edge cases, but I'd say this is most of what we're looking at is the 2 to 4 hour. I'm going to keep things moving here. We do have some time for questions at the end, but I want to make sure we can get through everything. So trend number 4, I'd say made in, and you can see I crossed out China here. I hate to put it so bluntly like that, but I think a lot of the legislation and rules that are coming out, and that would be both on the tariff side as well as the ITC provisions coming out of the One Beautiful Bill. Most of those are aimed at the fact that China really has dominated this sector. And so a lot of those penalties kind of fall disproportionately on China. There's a lot to talk about here, but I'd say the big trends are, you see that because of these larger tariffs on specifically China, as well as this provision in the ITC around FIAC, or foreign entity of concern, because of that, a lot of the suppliers were really trumpeting a couple things. Like one was if they're US made, or especially if they're either US, Europe, or a lot of in Southeast Asia, they're really coming loud and proud about that and trumpeting it. Chinese companies that were doing Chinese manufacturing have moved that manufacturing in large part to other places, such as Southeast Asia. They're very quick to tell you that. I think one of the really hard things with dealing this time in the industry is that the only certainty is uncertainty. You know, these rules keep sort of changing, even as they're written. There's a lot of ambiguity, and so it can be kind of hard to know what the rules are. And the IRS is coming out with guidance. It seems like every couple of weeks we get a new little bit of guidance. But you know, the companies are really trying to stay ahead of that. One nice thing is you're in an industry where the costs are falling so quickly that even if we're talking about a 50%, you know, adder onto the capex of a project, like we only have to look back 2 or 3 years to look where the price curve was 50% higher. You know, so it's sort of taking us back in time. And if we look forward, you know, it's going to keep getting cheaper. So I think it's definitely caused a lot of disruption in the industry, but a lot of suppliers are, you know, hustling to take care of that. I think they will find ways to do it. And of course, the silver lining of all this is that storage does have it a lot better than wind and solar. You know, wind and solar, the ITC provisions around the investment tax credit is winding up next year, whereas storage continues to have that accessible for the next 8 years or so, all the way through 2033. You know, I would highlight Norton Rose Fulbright is a great resource. They're an advisor on taxes, and they publish some great guidance on, you know, these sorts of things. So let's keep it moving along. These are, you know, 4 big trends we saw. I'm going to do quick 3 spotlights on 3 different companies. Again, we have no affiliation with those, and I hate to show too much favoritism for one or the other, but I do think it's helpful to look at a few specific manufacturers and kind of see how they've evolved. So I mentioned eStorage. They're a subsidiary of Canadian Solar. They're also known as CSES, Canadian Solar Energy Storage. You can see in 2021, they went from their SolBank 1.0 product. It was a 1.4 megawatt system up to 2-hour system. Same footprint, that same 20-foot shipping container. 2 years later, they came out with you know, nearly double. It goes up to 2.5 megawatts with the SolBank 3.0. There was a 2.0 in there also, but I'm kind of trying to just show 3 data points. And then the new one that they just announced was the one I was talking about before when I mentioned the AC block products. That's the FlexBank 1.0. That's a 4.2 megawatt up to 8.4 megawatt hours. So you can see that like those increasing cell densities are feeding the products, and also the AC block trend here is in effect. Of course, one of the other big suppliers everyone is talking about is Tesla. You know, in 2019, they launched their Mega Pack, you know, which was known as the Mega Pack. We look back at it now, it's Mega Pack 1. It was a single megawatt and 2.6 megawatt hour, so pretty close to where Canadian was. Actually, I think that number is wrong. Sorry, on my 2022, the energy number is right, the 3.9 megawatt hours, and it was that's 1 megawatt if you were to do the 4-hour system. It actually can go to just under 2 megawatts if you did the 2-hour. Fast forward to this year, they announced the Mega Block. So this is a Mega Pack 3, and they sell it in a Mega Block configuration, but now it goes up to 2.5 megawatt and 5 megawatt hour per unit. You can see some stats here. This was from Marek Kubek, he's a great voice on LinkedIn, but you can see this is, according to Tesla, they get that 91% RTE. That's really amazing. 10,000 cycles. I mean, it's a really long warranty. That's a 25-year warranty, 250 megawatt hours per acre. Really impressive product. I think this is going to be continue to lead the industry. And lastly, I looked at one of the leaders here was Fluence. Fluence Energy has been around since 2020. Their first product, this Cube Pro, was a 1.2 megawatt, 2.4 megawatt hour product. You can see it was actually, it's not quite a cube, but it's closer to a cube than a 20-foot shipping container. In 2023, they released this GridStack Pro product. You can see that 2.8 and 5.6 megawatt hour. And then the one they just announced here, this one was before RE+, but they moved to the SmartStack AC block product. Again, similar to the Canadian. So you see the inverters on the bottom, batteries on the top. Really impressive product. It's real tall. I remember seeing this in person. It's like, I think it's like 12 feet tall. Shipped, you know, they have some shipping concerns. They have to deal with these sort of things. But anyway, I think these 3 companies that I highlighted, they're really at the forefront of the industry, kind of showing this march along DC block to AC block, seeing the densities go up as time goes on. So really appreciate your time today. I know we're out of time. I'm able to stick around for a few minutes afterward if people have questions. Thank you so much. And if you want to stay in touch, feel free to reach out to me. I've included my LinkedIn information here and my email. So it's great chatting with you. I'm sure there's a few questions out there.